Students, this is the example based on collinearity. Collinearity is the part of coordinate geometry. When in last lecture I have explained you sum of two small distances should be equal to the greater distance. So we are solving first example of first no? Yeah, it is first example of question number 3. The points are A 1 minus 3, B 2 minus 5, C 4 minus 4 7. Clear? First we have to decide find what is the distance AB. What is the distance AB? So distance AB is AB. So these 2 points will be x2 y2 and these 2 points will be x1 y1. Which is the first? It will become x1 y1, and which is the second? It will become x2 y2. So according to our distance formula, under root x2 minus x1 the whole square plus y2 minus y1 the whole square, we put the values. X2 is 2, x2 is 2, x1 is 1, so 2 minus 1 the whole square, then plus y2 is minus 5, formula minus, this minus sign has come from formula, and minus 3, so minus 5 minus 3 the whole square. So 2 minus 1 is 1 plus minus 5 plus 3, minus 5 plus 3 the whole square, it will be 1 plus minus 2 the whole square. So it is 1. Squares are always positive. So first distance is under root 5. You don't have to find the values. Root 5. Correct? Similarly, for BC, for distance BC, we took again same formula, but this time BC means these will be x1 y1, these will be x1 y1, and these 2 points will be x2 y2. BC x1 y1 x2 y2, x1 y1 x2 y2, and after putting the values, x2 minus 4 minus 2, that is x1, so x2 minus x1 the whole square, then y2 is 7 minus from the formula minus 5 of x1 y1, so x2 minus x1 the whole square plus y2 minus y1 the whole square. So this become minus 6 the whole square, this become 12 the whole square. 36 plus 144, it is 180. Under root 180 is a complex number. We have to break it up. 2 into 2, 4, 4 into 9, 36, 36 5 You can write this way also. 36 into 5. 36 into 5. Both are equal, same. So 36 square root is 6 and this is 5. Now we are coming for distance AC. Distance AC. Distance AC means now A will be x1 y1 and C will be x2 y2. A will be x1 y1 and C will be x2 y2. By putting those values in the distance formula, you have done this. X2 is minus 4, x1 is 1, so minus 4 minus 1 the whole square. Y2 is 7, minus of formula minus 3 x y1, so it will be 7 minus into bracket minus 3 the whole square. Correct? 7 minus 3 the whole square. This becomes minus 5 the whole square. This becomes 7 plus 3 the whole square, 10 square. So 25 plus 100, 125. 125 is again complex number. So we have to split it. So perfect square is 25 into 5. So 5 came out and this is the answer. So now the condition. See distance here, distance AB, that is root 5. Here it is 1. You have learned cells in the last ninth standard. So 1 plus 5, it is 6 and root 5 is common. So distance AB plus distance AC will give us distance BC. This segment is like this. B is at this end, C is at this end, and A is in between them. So when sum of two small distances is equal to the greater distance, ABC points are collinear. Points ABC are collinear. This much simple calculation is there. 3 times you have to find the distance. 3 times you have to find the distance. I can solve all examples like this, but that will be called copying. So my request is personally you do the calculations on your own. How many examples are there? I have solved first one, second one, third one, fourth one. So 3 examples are remaining. I am requesting you to solve these examples. Condition is same. If sum of two smaller distances is equal to the greater distance, sum of two smaller distances is equal to greater distance, then the given points are collinear. Otherwise no. Simple. Sum of two smaller distances should be equal to the greater distance. If it is not there, right there, given points are not collinear. Without copying from the books or notes, you do on your own, that will make you perfect. So I am putting faith in you and you will solve these examples at home today only. Clear? Okay. Students, we are starting question number 3 of 5.1. This is important example in the point of view of examination. What they have said, find the point of on x-axis, point on x-axis, which is equidistant from these 2 points. So we have to first decide what is the condition. There is x-axis. On that the point is lying. So when point is lying on x-axis, its y coordinate is 0. When point lies on x-axis, its y coordinate is 0. Correct? Last year I had taught you these things. When point lies on x-axis, its y coordinate is 0. And when point lies on y-axis, its x coordinate is 0. So you must be remembering these points. If it is lying on the x-axis, it will be x0. If it is lying on the y-axis, it will be y0. 0y. correct? So if you know this, then it's easy. A point lying on x-axis, the y-coordinate is 0, and if point is lying on y-axis, the x-coordinate is 0. Remember this. So here it is a point which is equidistant from these 2 points. So let it be. Let the point be, say, ABC. Point B, C. Or let it be PQ. P. P. The point must be P. And P is on the x-axis. Therefore, y-coordinate of x or y-coordinate of P will be, must be 0. Therefore, we got the coordinates x is present, y is 0. We have to find these two. These two in the sense 0 is available, x, value of x we have to find. So it's very easy. See, the point P is equidistant from A and B. Therefore, AP is equal to PB. P is equidistant. Point P is equidistant. Now what they have said is, when these two are equidistant, when we find or want to find distance AP, for AP, that will be x1 y1, and this will be x2 y2, correct? So distance, by distance formula, distance AP is equal to distance PB. Distance AP is equal to distance AP. To find distance AP, we have to use the same formula. Therefore, under root A x1 y1, P x2 y2. So x2 minus x1 the whole square plus y2 minus y1 the whole square is equal to, for a moment you don't write anything here, first concentrate on this. So what will be this? X2 is x minus 3 the whole square, correct? x1 y1, x2 y2. So our x2 is x1 is x2 minus x, x2 is x and x1 is minus 3, correct? Plus y2 is 0, and y1 is 4, minus 4 the whole square. Similarly, now to this side, so we have put the values for distance AP. Now for distance PB, same formula, x2 minus x1 the whole square plus y2 minus y1 the whole square. So second step will be, who is x2 in PB? Who is x1 in PB? PB, or take BP. AP, BP, yes. So B is there. It is x1, y1. This time this will become x1, y1. And again this will be x2, y2. So x2 is x. x2 is x minus 1 the whole square. x1, x2, y2 and x1, y1. x1, y1, x2, y2. We need x2 minus x1. Who is x2? X. Who is x1? Who is x1? 1. Plus, in the another bracket, who is y2? 0. Correct? And who is y1? Minus 4 the whole square. So, instead of doing these all things, we have to remove the square root sign. Squaring both sides. We'll get x plus 3 the whole square, x plus 3 the whole square, and 4 the whole square plus 4 the whole square is equal to this side, x minus 1 the whole square plus 4 minus 4 the whole square. Squares are always positive. So therefore x plus 3 the whole square plus 16 is equal to x minus 1 the whole square plus 16. These two gone. Therefore, now this is the identity where x plus 3 the whole square and x minus 1 the whole square, we have to expand both the sides. When you expand these brackets, we are going to get a plus b the whole square, that is a square plus 2ab plus b square, that is x square plus 6x plus 9 is equal to, this is a minus b the whole square, so x square minus 2x plus 1. Correct? You can check. You are in 10th standard now. You don't have to write all the steps. Quick answers and quick calculations. So this x square and this x square gone. What we are having is a 6x plus 9 is equal to minus 2x plus 1. Therefore, 6x plus 2x is equal to otherwise same plus 9 minus 9 plus 1 So now it is very easy to calculate the value of x. So 8x is equal to minus 8. Therefore x is equal to minus 8 upon 8. So x is equal to minus 1. What is x? X is the coordinate of P and y coordinate is 0. Therefore, P corresponds to -1, 0 is the point which is equidistant from A and B, and coordinates A -3 4 and B 1 -4 1 -4. This concludes the example. A and B are 2 points. P -1 0 is equidistant from A and B. So this is the most expected example in your exam. Clear?